The Cycles Research Institute.
Cymatics. I want to talk a little bit about some of my own experiments with cymatics, but first I'd like to give a little bit of background. Hans Jenny is the guy that coined the name cymatics, and he referred to vibrations in either powders or fluids, where they were set vibrating by some mechanism, and then he either photographed or filmed them, and some of the things are pretty spectacular. This is from the cover of his book, and you can see the interesting shapes that develop. He was followed also by Sir Peter Guy Manning, who both Hans Jenny and Peter Manning were doctors, and they had some applications towards health of this as well for those that are interested. A long time before he did this work, there was the fellow Chladni who had vibrating plates, which made interesting patterns as well, and this sort of developed further from what was done then. So that's a little bit of the background. I highly recommend anyone to get on YouTube and have a look for cymatics, and you'll find lots of fascinating stuff. Some of the things look, with just two frequencies, he was able to make powders move around into a position that they look like a centipede, and even with their legs moving. So if we can make something that looks like that with two frequencies, maybe with quite a few frequencies, we can make something that looks like a human being. Maybe we can't, but maybe the universe did. In my own experiments, well, first of all, I started with a cup of tea. This was how I got interested. I had a cup of tea, and I noticed when I put it down on the table, a little wave came in, a circular wave came in from the outside, and got more concentrated near the middle. And I started jiggling the cup of tea up and down, trying to find the resonant frequency. And eventually I got it, and a jet of hot tea went in my eye. At that stage I decided it's a little bit better to have a controlled experiment. So what I did is I took the speaker, a computer speaker, turned it on its side, mounted some little plastic thing in a little dish, and I tried with powders like and sand and stuff like that. It's just climbed over the side and fell on the speaker. So I ended up putting water in the dish. So this is the arrangement I had, and I could control what frequencies and what volume I played and what sounds from the computer, and had a controlled experiment for doing this. So then I began to put some frequencies and see what happened. So that's the apparatus. Mm-hmm. In the experiment, I had the dish, I had the camera pointing here, and I had a light source over here. So where the water was flat, the light would come off the surface and into the camera. So any places we see that are light here, it means that the surface of the water is horizontal. Any places that are dark, it means the surface of the water is tilted in some direction. Mm-hmm. And so it allows us to see it. Now, this is one frame from a video. I took videos of this happening, but it's interesting. We can see a number of things in this. We can see a series of little circular patterns here at more or less equal distances from each other. Some other ones floating around. We can also see these little ladders running out to the side in various number of places. So it's quite an interesting pattern. Now, when I first started it, it went through a series of steps. I'm just going to check if those are on there. We may have to edit this. I haven't got those on there. I have got pictures of those somewhere. Never mind. When I played a low volume of sound, what happened was there was circular wave pattern coming into the middle, and just one circular pattern in the middle, and the others coming out from it. As I gradually increased the sound, suddenly from the circular one in the middle, 6 more circular ones appeared around it. Like you can put a coin and 6 other coins around it. That's the pattern you got. And it had these little ladders, but the thing was basically stable. It might rotate a little bit, and it sat there. Yeah. When I increased the volume a bit further, it suddenly changed to this pattern, which had a lot of these little circles, and they were all dancing around, but maintaining their distances relative to each other. And these ladders were moving around and that. If you reduced the volume, it would change back to the one with the 6 around the one, and then back to the 1. So you couldn't get anything in between those. So what we've got here is something that, if we think of these as particles or something like that, which I can't help but look at them as, then what we've got is changes of state. We've got 3 different states that the thing can exist in at different energy levels, much like we have solid, liquid, and gas, and with matter. Now remember, this is only 2-dimensional. In the universe, I'm imagining that this sort of wave structure is happening, not just confined to a disk, but over the entire universe, and that these little things coming in are the waves from elsewhere. In this case, they've reflected off the side and come back. But if there's other things elsewhere in the universe, we can imagine them going in and out. This is an expansion of what's in the middle of that one, and I've labelled them with letters and in two colours. The reason I've done that is that as we look at any wave, if that one is high, if that's the peak of a wave, and we know that it's either the peak or the trough, because it's horizontal, then the bit in between here is the sloping part, and then if that's the peak, that'll be the trough. That'll be a sloping part. These will be then peaks again. These will be troughs, and those will be moving parts, so those will be troughs. So if that's a peak, those two are troughs. And if we count 1, 2, 3 half waves, that's 3 half waves away and 3 half waves. These are all 3 half waves from that, but 2 half waves from each other. So what we can say is when the blue ones are up, the red ones are down. When the red ones are up, when the blue ones are down, the red ones are up. Right, they're flip-flopping. So in taking those ones, we've actually got this sort of a pattern, tung, 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 like that. Now, when we think about particles and wave structures, this could be an explanation for charge. We've got 2 different charges. These 2 are the same charge as each other, and these 4 are the same charge as each other. So we've got these distance structures, and in this sense, each of these waves is supporting each other. The wave that goes out from this one wavelength, you can see a bit more of the wave there, that the next wavelength's going through there, the next one through there, and so on. This one, we can see the waves coming out through here, and the waves coming out this way. So each of these is either a whole number of wavelengths apart if it's the same polarity, or something in a half wavelengths apart if it's the opposite polarity.
I see.
That's not the only thing that's going on. We can put a series of lines here at half wavelength apart, which actually picks up, that's a blue, that's a low, that's a high, that's a low, that's a high, that's a low, that's a high, that's a low. Those are both highs. In that case, there will be one of these little ladder patterns going out there. So a straight wave coming through here that fits in with every one of those makes a straight wave going out to the side, bouncing off and coming back again and supporting it. That's happening in 8 different directions.
Wow.
This is just showing the wave structures of those circular waves that I mentioned before. How they all are united and all agreeing on what polarity each of these points should have. So this is a way that we can see that in this confined space anyway, we can have stable particles. They can move around a bit, but they want to maintain their particular lengths with each other, which in the case of, if they were atoms, we'd think of them as bonds. If they were particles, we would think of them as the separation of particles in the nucleus.
And I can see you have patterns of a vesica Pisces between adjacent poles of a like nature.
A couple more pictures. So this is sort of just summarizing the thing here. This is the pattern. That's just one frame from a video, but if we watch the video, these are remaining stable. Some of these other ones may be bobbling about a bit. And we can see here, I've shown you the pattern that makes these little ladders. We can see these ladders going off in each direction. And each of those, in 8 different directions, we can do this thing with the red and the blue alternating. And going through all of those points and all maintaining, like we can put a red one there, a blue one there, a red one there, a blue one there, so on. Red one, blue one, red one. And so we can get that structure. And so these things, the energy that's going out from them that they're radiating, are supporting each other directly, and after bouncing off the outside, coming back in and supporting each other again in themselves. And this is how they continue to exist. In this case, we need a driving force to keep vibrating it, because the losses of energy in the system mean that those waves get lost. But if we imagine in the universe, we can't lose it because there's nowhere else for it to go. It has to be in the universe. It keeps on going. So that gives us an idea of what's happening. This is a cymatics experiment, but I think it's particularly interesting as it gives us insights into what may be the wave structure of matter, which we've got separate talks about happening, and we've got other diagrams showing what might be going on in those. This is just a 2-dimensional one, but it gives us some clues because it shows us the possible basis of charge, and it shows us that why there are particular wavelengths that things want to be at distances of, and these sort of things turn up in quantum mechanics that are half wavelengths and whole wavelengths, according to the different types.
Yeah.
So these things, they're real experiments, but they give us insights into other things that we can't see because they're too small.
Mm-hmm. Yes. Yes, because patterns repeat on large and small.
So what we see here are the 4 ones that were arranged in a sort of a square, 2 blue and 2 red. Yep. And what this is showing is how the waves going through those by going red, blue, red, blue, red, blue like this. We've picked up that red, that blue, that red.
Yes.
And we've done this direction, those 2 directions, and those 2 directions. We can do a mirror image of that as well, and we get 8 directions altogether.
Oh.
So this is what this will explain 8 of those little letters that are running out in all the directions, why they form around those.
Yes.
The Cycles Research Institute. cyclesresearchinstitute.org